This is Soman from IIT Kanpur Department of Chemistry. So today I am going to discuss about this the brief introduction of this polymer chemistry. Okay, so coming to the first one, the polymers. What is the polymers? We all know that polymers are high molecular weight molecules formed by many small units that is called monomer. And okay, then what is the monomer? The small unit which can make long chain molecules, that is called the monomer. And you can see the picture like small unit after polymerization that is forming a polymer. This is the process where polymer can form, and the process is called as polymerization, and the small units are known as the monomer. Okay, now coming to the main point, this is the repeating unit. What is repeating unit? In polymer chemistry, repetitive unit is a part of polymer whose repetition would produce the complete polymer chain. Like if polythene, we know that polythene is a polymer compounds, but the polymer, this polythene is forming from a CH2 molecule from the ethylene. A number of monomer units of the ethylene molecules in this polymerization process, they will form this polythenes, polymer compounds. So that's why the ethylene molecule is known as the repeating unit in the case of the polythene. So here I have shown some of the repeating units like CH2 CBr, and this bond will be another repeating unit. Then again another repeating unit will come. Like this way one polymer chain will form. This is the why this is way one polymer can form. Now, coming to the degree of polymerization. The degree of polymerization is defined as a number of monomer unit in a polymer. So, and if you see the mathematical expression of this degree of polymerization, dP is shortly named as the dP, the MW over MO, where MW is the average molecular weight of the polymer and MO is the molecular weight of the repeating unit or the monomer. So, point to be noted, this type of expression always mathematical expression always come in CSIR or CSIR net or GATE exam. So maybe this is very important. Even you can go and check some of the in previous exam papers. You can see some of the mathematical problem will come definitely. Either two number or four number question. There will be one question in the case of CSIR. I'm talking about. And even GATE exam also it came in the previously it also came in the GATE exam also. Okay. Also we will discuss about the which point is very much important in for the competitive exam in chemistry. In the case of what kind of question came from this polymer chemistry, I just cover it all this. I just cover those points whatever very much important in this like a CSIR, NET, GATE, TIFR, or any type of MSc type of MSc admission test or many PhD admission test. So, okay, in the next slides we will see some of the important question. Okay, now coming to the classification of this polymer. So there are four types. So one is the on the basis of the type of monomer unit, and the second one is the on the basis of the skeleton structure, and the third one is the one of the on the basis of the technicity, and fourth one is the on the basis of nature. Okay. Now coming to the first point, what is on the basis of the monomer unit. So monomer units has two types. One is the first one is the homopolymer, and second one is the heteropolymer. So yes, here is the important question is they can ask the homopolymer example of the some of the homopolymer. Like here I have shown polyethylene, PVC, polyvinyl chloride, and polystyrene. And the heteropolymer example of the heteropolymer, the this is the Buna-S, Buna-N, and the block copolymer, alternative copolymer, and the random copolymer. So you can see what is the block polymer. What do you mean by block copolymer? you can see the structure, you can see the picture, and from that you can easily understand what is the meaning of the alternative copolymer. Obviously there are two structural different structural unit will be alternative way, and the random means the randomly they can arrange, they can they can arrange in a different means randomly. And the block copolymer means the two different types of two different types of structure will be there, and they are also arranged in such a way that this is called as the block copolymer. Okay, now coming to the on the basis of the skeleton structure. So this is also three types of polymers are known. One is the linear, the A number one. This is the picture you can see. That's why I have taken some of the pictures so that you can easily uh, understand, easily get this point. So now coming to the second point is the branched one, where one of the or two branch, three branch, even four branch can happen in this polymer. And the third one is the cross-linked or the network system. Like cross-linked, why it is cross-linked? Like if two three structural units can be cross-linked by in such a way that it will form definitely a cyclic system, cyclic type of intermediate. So that's why it is known as the one type of network system. This is just one of the structural unit I have taken. If you see the whole picture of the structural unit, it's just like a network. So that's why it is known as the cross-linked or network. Okay, so yes, this is the important thing. Here I'll tell you one thing. This is the linear polymer, this is high density polythene, and branch polymer, this is low density polythene, and the cross-linked polymer is the bakelite. Yes, there will be some question in future, even the previously also they have asked this type of question. Example of this linear polymer are in the MCQ type question, though this is high density polythene or low density polythene, linear polymers or branched polymers are high density polythene or low density polythene. This type of question came in previously in CSIR. Okay, so this is also important. Note down is all these things. Okay, now coming to the on the basis of the technicity. So on the basis of the technicity, polymers are three types. One is the isotectic polymer, and the second one is the tactic polymer, and the third one is the symbiotic polymer. So in the case of isotectic polymer, side group of the monomers lie on the same side of the chain, and the tacticity of this polymer, atactic polymer, is the side groups are arranged in an irregular or random manner in the main group. The third one you can see the picture, you can see the randomly they have they are arranged in a randomly. And the third one is the symbiotic polymer, where the side groups of polymers are arranged in an alternative way. Okay, in the case of symbiotic only they are arranged in an alternative way. Okay, okay, now coming to the on the basis of the nature. On the basis of the nature, there are also three types of polymers are known. One is the natural polymer, second one is the semi synthetic polymer, and third one is the synthetic polymer. So in the case of natural polymer, the examples is protein, cellulose, and the starch, rubber. And the semi synthetic polymer, cellulose derivatives, cellulose acetate, rayon. The examples is rayon. And the synthetic polymers are buna S, buna R, nylon, polythene, and polyester. Some of the polymers, the summary, the gist of the sum of the polymer will see in this video only. Okay, and now why the polymers are so much important. So if you see anywhere, if you see anywhere around you, there are polymers. Like some of the some of the picture I have taken, you can see man-made synthetic polymers are like plastic containers, contact lenses, toys, sports equipment, clothing polyester. And the natural polymers are like DNA, wooden, rubber, carbohydrates, and protein amino acids. And now coming to the polymerization. So what is polymerization? the process in which the formation of the polymers happen from the a monomer unit. And the polymerization, as two types of polymers are known. The one is the addition polymerization and the second one is the condensation polymerization. Okay, now first one is the, we'll discuss first the addition polymerization. If you start with the ethylene gas molecule, no, this is known as the monomer, and you can end up getting this polythene polymer without any side product, without any byproduct. This is known as, the process is known as the addition polymerization. And now coming to the condensation polymerization. Condensation polymerization is a form of step growth polymerization. So linear polymers are produced from bifunctional monomers, that is compounds with two reactive ends group. Common condensation polymer includes polyamides, polyester, and proteins. Like they have mentioned that the bifunctional monomers two reactive end group means the one of the structural unit, there should be one OH, or in another unit there will be some NH2, so that the condensation, after condensation there will be a release of only water as a byproduct, nothing else. Okay, you can see this, how this water is coming out from this condensation polymerization, and you will end up getting, if you start with the amino acid, you will end up getting protein and water as the byproduct only. Okay, now coming to the natural rubber. Natural rubber is a polymer, a long chain like molecule that contains repeating subunits. Like if you start with the isoprene, there will be formation of the natural rubber. This is called as the polyisoprene. The structural unit always will be the isoprene molecule, and there will be a lot of in numbers of isoprene molecule in the polymerization. After polymerization get happens, and you will see this natural rubber where the main structural unit will be the isoprene. Okay, now what is natural rubber? The monomer unit of natural rubber is a isoprene unit, like I have said earlier. And it is a type of homopolymer. Homopolymer, why? Only the same type of monomer units are there. The formation of the natural rubber is addition polymerization process. The polyisoprene or isoprene that we obtain from rubber tree latex is very poor quality. To improve the quality of the rubber, vulcanization process is done. In vulcanization process, the linear polymer become cross-linked polymer. For this purpose, the sulfur is used, and 140 to 160 degree centigrade temperature is induced. Now, if you see sulfur crossed linkage, this one of the polymer unit I have shown here, and if you see, if you react with the sulfur, it will form this sulfur cross linkage. You can see in the CC bond will be linked by CC double bond will be break, and another CSCS bond will form. This is how the sulfur cross linkage will form. Now coming to the Buna ash, how this happens. The if you start with the 1,3-butadiene and styrene, in the presence of sodium heat, polymerization happens, and butadiene styrene copolymer will form, and this is called as the SBR. Why SBR? Because this is a styrene butadiene, and or also known as the Buna ash. So in CSIR and GATE, they can also ask this Buna ash can be, how one can form this Buna ash polymer. So there will be option 1,3-butadiene, styrene, or maybe some other options will be there. So you can simply take this. If one of the option will be there, Buna ash from this 1,3-butadiene or styrene, you can click it. Okay, now coming to the Buna N. we already see how what is the Buna is. Now coming to the Bunaen. Bunaen is the 1,3-butadiene, and here not styrene. In the case of Bunaes, there was the styrene molecule, but here 1,3-butadiene is the same, but only thing is that here the changes is the acrylonitrile CH2 double bond CHCN. After polymerization, you will end up getting this type of Bunaen structural unit. Okay, now it is clear what is the difference between Bunaes and Bunaen, where the Bunaes where only unit the difference is the styrene in the case of Bunaes, and in the case of Bunaen only acrylonitrile will be the difference. Okay, now coming to the nylon 6, due to presence of the 6 carbon atom in monomer unit, it is called nylon 6. Now if you start with this caprolactam, and after heating you'll end up getting this nylon 6 molecule. Yes, you can get this nylon 6 molecule. Yes, now how this nylon 6 molecule can be formed? If you start with the adipic acid, COOH, CH2, 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 4 CH2 group will be there, and 2 carboxylic acid group unit will be there. And as I said, the condensation reaction always there will be at the end, two reacting groups should be there. One is the acid and another here another is a hexamethylene diamine. So if you just condensation happens, and water will be the byproduct, and you will end up getting this nylon 6 molecule. Yes, now we'll discuss about the difference between thermoplastic and thermosetting polymer. Okay, so what is the difference between thermoplastics and thermosetting polymers? So the first point will be the in the thermoplastic polymers are softened on heating, but thermosetting polymers are not softened like thermoplastics during heating. Now the second point is the long chain linear, but in the case of thermosetting polymers they are the 3D structure, and thermoplastic polymers can be formed by the addition polymerization, but the thermosetting polymers can be formed by only by the condensation polymerization. This is the main difference, where the thermoplastics can be made from the addition polymerization, and thermosetting polymers can be formed by only condensation polymerization. And the fourth point will be that can be reshaped and reused, but in the case of thermosetting polymers you cannot be reshape this molecule. Okay, now and the fifth point is the soft, weak and less brittle, but in the case of thermosetting polymers they are very hard and strong, and due to this softening in nature they are very much soluble in organic solvent in the case of thermoplastic polymers, but in the thermosetting polymers are insoluble in organic solvents and reclaimed for the wastage worst in the case of thermoplastics, and the thermosetting polymer cannot be reclaimed. These are the main difference between thermoplastic and thermosetting polymer. Okay, now can be melted repeatedly. If you see this picture, why I have chosen this picture, because there was the difference. So this is the picture of this thermoplastic and thermoesters. So thermoplastics, these are the toys, the left side one, it can be melted repeatedly, but one shaped cannot be melted. Thermoester one shaped cannot be melted in the thermoester. Now to the use of polymer, new packaging materials, waterproof coatings for fabrics, example for outdoor clothing, and filling for teeth, dressing for cars, hydrogels, examples for soft contact lenses, disposable nappy liners, smart materials, examples safe memory polymer for shrink wrap packaging. Okay, now coming to the polymer nano fiber tissue. One is the wood dressing prevents scare bacterial shielding. The second one is the medical prosthesis. This is the lower stress concentration, higher fracture strength. And the third one is the homeostatic devices and the higher efficiency in fluid absorption. And the fourth one is the sensor devices, and it is higher sensitivity for cells, arteries and veins. And electrical conductors, ultra small devices. Optical applications, liquid crystal optical shutters. Material reinforcement, higher fracture toughness, higher delamination resistance. Protective clothing, breathable fabric that blocks chemicals. Filter media is the higher filter efficiency. And cosmetics, higher utilization, higher transfer rate. And drug delivery is the increased dissolution rate. Drug nanofiber interface. And the tissue engineering scaffold is the adjustable biodegradation rate, better cell attachment, controllable cell directional growth. These are the polymer nanofibers. Okay, thank you for watching this video. Will come quickly another video, some interesting video. Okay, thank you, and please subscribe my channel.